By the way, if you have classmates that if you have classmates that are not yet aware na we are conducting classes, please let them know, no? Some of my students sa other section, di pa daw sila aware na kukwis na kami tapos hindi pa sila nakaka-attend. So, please let them know na we already started the semester, and in fact, magkukwis na kayo tomorrow, no? So, let them know na lang, especially for those who are not from your block, no? Or yung mga late enrollees. Okay? So, yun. So, thank you. Anyway, so let's continue our discussion sa chemistry. So, we are now in the chapter 2, and our focus would be on atoms. No? So, our topics to be included here ay yung history of atoms, then what are the constituents of the atom, and then um, ano pa yung pwede natin malaman about atoms. Okay? So, yun lang muna yung i-discuss natin for now. So, let's continue. Okay. So, we know that our body, in fact, is composed of different atoms, no? And these atoms combine in different proportions, no? To create molecules, no? That allow life to be possible, no? Okay. So, ito rin yung mga atoms na to, these are the reason why we behave in bad time. Minsan naka-good mood, nasa good mood na yung behavior natin ay positive, minsan bakit negative, no? So itong mga atoms din na to ang may pinakakasalanan talaga, no? Sila yung pinakasanhi ng lahat ng nangyayari sa atin, no? So they are the primary reason why we existed, no? So pero before the modern period, yung period natin ngayon, nung unang panahon, they do not have any idea saan sila gawa. Okay? So, tayo alam natin, yes, we are composed of atoms, no? Okay, our bones are composed of calcium, our blood has iron, etc., etc. Pero, the people in the olden times, they weren't aware, no? So that's why they hypothesize the on the on the basic unit of everything sa universe. Okay? So, parang nag-hypothesize sila, saan kaya gawa lahat ng mga bagay before? Okay? So, kumbaga, pupunta muna tayo sa atomic history. Okay? So, let's start the with the idea presented by, actually, before Democritus, punta muna ako kay Aristotle. So, Aristotle, medyo matagal-tagal to. Okay. So si Aristotle, he was one of the greatest philosopher, 'di ba? Saan siya kilala? Sa halos lahat ng field, no? Meron siyang say about politics, meron say siya about theology, no? So masyadong malawak ang kanyang expertise, no? And even sa science, no, may naiambag din siya. Okay. So Aristotle hypothesized that everything in the universe, no, or everything on Earth is created by four different elements, no. Dito ang basis ng avatar. San gawa daw ang lahat ng bagay? Gawa siya sa fire, sa earth, ay, gumagalaw, sa water, and sa air. Okay? So this was Aristotle's hypothesis, no, that everything is composed of the four basic elements: the fire, earth, water, air, no. Ang abbreviation ko diyan ay FEWA, no. So kung familiar kayo what FEWA is, tanungin niyo yung mga friends from PUP, no. Kasi doon ako galing nung undergrad. So FEWA, fire, earth, water,
Yes.
air. May taga PUP dito, no? Sarap ng FEWA. So, yun yung start ng lahat ng idea about science. Okay? So, isipin natin, paano kaya naisip na Aristotle yan? Kasi ganito daw. For example, you have a paper. Siyempre, tayo, mga philosopher tayo, kunwari. Kunwari tayo si Aristotle. Saan galing yung papel? Yung papel galing sa puno. Tapos susunod na tanong, saan galing yung puno? Sa lupa. O, galing siya sa earth, no? So, everything na galing sa earth, galing sa lupa, dun siya nagbunga, gawa daw yun sa earth element. For example, prutas. Saan galing yung prutas? Di sa ganitong halaman. O saan nanggaling yung halaman na yan? Sa lupa. Di earth element yon. Okay? Nari, itong kahoy, itong pinapatungan ng laptop ko. Saan to gawa? Sa puno. Saan galing yung puno? Sa lupa. So basically, lahat ng lumaki from the earth, no? Whether halaman yan, kahoy yan, prutas yan, or gulay, or pagkain, lahat yan galing sa earth. Okay? Then, next one is water. Lahat daw na nagpo-flow, gawa siya sa water. Okay? So, for example, yung laway, no? Yung inumin, yung alak, yung tubig, no? Lahat ng yan, basta liquid ang form. Gawa daw yan sa water. And the next one is the air. Ito daw yung mga particles that cannot be seen yet nafe-feel mo. Bugahan mo yung sarili mo. O, yung gawa daw yun sa air elements, no? Then yung fire, they characterized fire as an element, no? 'Di ba? Nakikita mo pag nagsindi ka ng apoy, yung kulay pula siya. Tapos may nagka-crack-crack doon, 'di ba? So sabi ni Aristotle, yung mga nagka-crack-crack diyan sa apoy na yan, that's fire element. Okay? So kumbaga, ito yung pinaka idea ni Aristotle that everything was really made of fewa, no? The fire, earth, water, and the air, no? Okay? And that was accepted before. Why? Because, number one, Aristotle is famous. Parang nagkaroon ka na lang ng conformity, di ba? Ayan, sabi niya, famous yan. Di sige, totoo yan. Okay? So, yan. Aristotle's idea was accepted before. Okay? And then, dumating si Democritus. No? Okay, so Democritus was also a known philosopher and may say siya about anything din sa math, sa philosophy, sa religion din ata. Meron din siyang say, no? So, para lang siyang Aristotle, no? And he contested Aristotle's idea. Okay, so paano niya kinounter yung idea ni Aristotle? This was Democritus' idea, no? So, kumuha siya ng papel. Itong tissue paper na lang. Kunwari, ito yung papel. Ako si Democritus, tapos ito yung paper ko. Okay. So, try mo daw yan hatiin into two. Parang ayaw ko tuloy punitin yung tissue. Ito na lang. O yun. Sticky note. So, kunwari, ito daw yung papel. Try mo daw yan hatiin into two. Hindi ko siya nahati into two, pero basta nahati ko siya. Okay, so ito na yung paper natin. Tapos try mo pa daw yan hatiin into two. Okay? So, napapansin nyo, lumiliit pero pwede mo pa siya hatiin. So, try mo pa daw yan i-cut into two. Further. Cut it further until ano yung mangyayari? Until you will come to a point that you can no longer cut the paper. Okay? So, kunwari ito, nahihirapan na ako putulin yung papel. Pero kung kaya pa, tuloy mo lang. Yun yung idea ng Democritus. Pero sabi niya, eventually, you will come up to a point in which you can no longer cut that particle. You can no longer cut the paper. And that was the basic unit of everything, no? Yun daw yung basic unit ng lahat ng nag-exist sa universe according to Democritus. And he called it atomos. So, atomos meaning uncuttable. Hindi na mahati sa gitna. Okay? So, yun yung idea ni Democritus, no? Kunwari, ikaw, hatiin ka sa kalahati, tapos kalahatiing ka. It will come to a point na hindi ka na pwede hatiin pa, no? Darating ka na sa point na singular na yan, no? Hindi mo na pwede siya mahati at all. Okay? So, that was Democritus' idea. Okay? So, medyo medyo parang mind-blowing during that time. Okay? So, sino papaniwalaan mo? Si Democritus ba or si Aristotle? Kunwari, ikaw, nasa lumang panahon. Sino papaniwalaan mo? Si Aristotle na obvious yung sagot that everything is made of fewa? Or si Democritus na sinabi, hatiin mo lahat. You will come to a point that you will have atomos or the uncuttable. Sino papaniwalaan nyo doon? Ako kasi, kung ako nabubuhay nun, I will believe in Aristotle's idea. 'Di ba? Kasi obvious eh. Okay. So ganun yung nangyari before. They accepted Aristotle's idea compared to Democritus' idea. However, as the understanding of science improved, no, from philosophy, nagkaroon na tayo ng another form ng knowledge, which is yung science. Nagkaroon na ng further inquiry about math, about the existence of everything. Doon na na-confirm na medyo logical pa si Democritus compared to Aristotle, no? Okay? Kasi imagine nyo na lang, kapag hinati-hati mo yung earth element, di ba, it will be uncuttable then. No? You will come up with an atomos. Same with the fire, same with the water, same with the air, di ba? So, kumbaga, pag hinati mo lahat talaga, mapupunta ka sa atomos. So, they favored Democritus na later on. No? So, after ilang century, doon na natanggap yung idea ni Democritus that this is scientifically uh, accurate, no, or accepted, no, that everything ay composed of atomos. Okay, so doon na nag-start yung belief sa atoms or atomos. Okay, and then later on sa sa buhay, okay, so around 17th century, the late 17th century, nagkaroon na tayo ng nagkaroon na tayo ng alchemy, no? And then later on naging chemistry na siya, no? So anong ginagawa ng alchemy? So it is chemistry lang, no? It investigates on what can you do about the matter kasi naniniwala na sila about atomos. Okay? And then there came John Dalton, no? So si John Dalton, this is a chemist which also focused on the idea of atoms. No? So yun yung niya, focus ng inquiry niya. Ano ba talaga yung atoms, no? So in his study about atoms, he came back with the Democritus idea, no? With Democritus idea, yung atomos. Okay? And then later on, he conducted several experiments, no, to verify the concept of atomos, no. So gumawa siya ng experiment whether yung idea ba ni Democritus that will reflect the atoms today, no. And he found out that it was true, no. Lahat ng sinabi ni Democritus about the atoms ay true according to John Dalton. Hence, he come up with the Dalton atomic theory. Okay? So, parang si Dalton, ano ginawa niya? Verify niya lang yung sinabi ni Democritus. No? Other than verification, in-expand niya pa yung knowledge, no? So, gumawa siya ng several chemical experiments, no? And then, na-confirm nila na, okay, true to. And he presented his atomic theory, okay? And the atomic theory goes as this, no? Number one, matter is made up of very tiny, indivisible particles called the atoms. 'Di ba ito yung sinabi din ni Democritus, okay? So, Dalton affirmed that everything is made of atoms, no, according to his experiment, no, thousands of years after the death of Democritus. Okay, so totoo pa rin siya until now. Next one is that atoms of a given element have the same chemical properties. So that means yung atom daw ng isang element, iisa siya ng behavior. Okay, iisa sila ng behavior. Let's say oxygen, ano yung behavior ng oxygen? It allows combustion reaction to occur. No? Without oxygen, walang masusunog. Okay, so yun yung behavior ng oxygen. Um, it helps the combustion reaction to occur. No? Kunwari, ano naman, let's say carbon. Ano yung behavior ng carbon? Kulay black sila. Okay? Pag sinunog mo yung organic matter, for example, puno, okay, papel, magiging black yon. Yung black na yon ay yung carbon. Okay? So, anything na organic, pag sinunog mo yan, you will have carbon. Okay? So, kumbaga, yung mga elements, kahit anong form man sila, pag kinuha mo sila in their elemental form, no? Yung atoms, kahit anong form yan, puno man yan, papel man yan, kahoy man yan, no? Kapag kinuha mo yung mga elements from that, they will still behave the same. Okay? So, yun yung second idea ni Democritus, no? Na regardless, no, of the form of your atom, as long as they are of the same element, they will behave similarly. Okay. Number three, in ordinary chemical reactions, no atom of any element disappears or is changed into an atom of another element. Okay? So, kumbaga, itong number three, this is called the law of conservation of mass. No? Pakinote na lang ha. Okay, so number three is the law of conservation of mass. No? It tells us that in every chemical reaction, whatever your atoms are present, yun din yung present after carrying out the reaction. So walang mawawala, walang susobra, and higit sa lahat, walang mapapalitan na atoms. No? Kunwari, kunwari, sinunog mo yung papel. Pag sinunog mo yung papel, kung ilan yung carbon atoms doon, ganun din karami yung carbon atoms after the chemical reaction. Okay? So, yun yung law of conservation of mass. No? It tells us that yung atoms, hindi sila mawawala. Okay? Excuse me. So, hindi sila mawawala ng kusa. Hindi rin sila pwede madagdagan. No? Kunwari, nagsunog ka isang papel, isang lumabas, isang kilong uling. Hindi ganun. Okay? So, kung gaano karami yung atoms mo initially, ganun din dapat karami yung atoms mo after. That's the law of conservation of mass. No? Okay, so next in Dalton's atomic theory is that etong 4 and 5 magkadugtong na yan. Okay. So according to the fourth postulate is that compounds are formed by chemical combination of two or more kinds of atoms and molecules are combination of two or more atoms. Okay, so basically magkasama lang to. Okay? Kadugtong yan. So sabi diyan, no, whenever you combine one atom and the other atom, no, to form chemical bonds, you are creating what's called a molecule, no. For example, you add hydrogen and oxygen, no. Pag pinag-add mo yung dalawang hydrogen at isang oxygen, you will come up with water. Okay? And the chemical properties of that compound, no. Yung compound yung pinagsamang elements. Ang chemical property nun ay mag-ibang-iba sa elemental form. Kasi tignan mo, hydrogen that is combustible, water, nasusunog ba yung water? Hindi nga 'di ba? Oxygen that helps in combustion, water, nasusunog ba? Hindi rin, okay? So kumbaga, pag pinagsama-sama mo yung elements to form compounds, to form molecules, no, their chemical properties are different, no? Okay, so ganun lang yung idea ni Dalton. Okay, so all those four postulates, four lang yan, magkadugtong tong 4 and 5 eh. Okay, so all those four postulates helped us, no, to have a clearer idea about the atoms, no. So we only ano lang tayo, nagbigin lang tayo with the idea of Democritus na may atomos. Ngayon, through Dalton's experimental results, no, alam na natin na may iba pang properties na kaya gawin yung ating atoms, no. So, yung apat na yan ang gagabay sa future researchers ng science, no, in discovering more about the atom. Okay? So, kumbaga nag-uumpisa pa lang tayo sa history niya. Okay? So, ano kaya itsura ng atoms during Dalton's period, no? So, Democritus hypothesized that atoms look like this, no? Okay, so para siyang circle or square, no? Na hindi mo na siya mahati. Okay, so cube yan or spherical shape na uncuttable. So, during Dalton's time, hindi na niya pinalitan yung ganong concept, no? So, according to Dalton, ang itsura ng atom ay spherical pa rin. Okay? So, spherical pa rin yan na hindi mo mahati. Okay? So, same concept lang. Okay, so we're done with Dalton. Ngayon, punta naman tayo kay Thomson. Okay. Si Thomson, eto, meron na siyang kuryente during that time, no? Okay, so around this time, 1856, 1910, 1940. Umabot siya ng World War. Okay. So during that time, nagkaroon na ng Industrial Revolution, and then later on, nagkaroon na tayo ng kuryente, di ba? So ibig sabihin, pag may kuryente, more possibilities na pwede gawin sa experiment, no? And yun yung ginawa ni Thomson. Okay? Paano? Okay. So si Thomson, may kuryente siya. Okay. Tapos anong ginawa niya? Kinuryente niya yung atoms. Okay. So, ang tawag sa experiment na ginawa niya yon ay yung cathode ray tube experiment. Wala tayong picture dito eh. So, kumbaga, meron siyang CRT, cathode ray tube, no? Kung familiar pa kayo sa lumang TV, yon, yung malaking TV, 'di ba pag binuksan yung likod nun, may ganyang itsura. So, yun yung cathode ray tube. Okay? At the end of that cathode ray tube, there is a filament, no? May filament, may metal dun sa dulo. And that is connected to to the external source ng kuryente. Okay? So nakadugtong 'yan sa kuryente. Kunwari yung black yung negative, yung red yung positive. Nas yan yung kuryente. So what will happen? So sabi ni Thomson is that pag kinuryente mo yung atoms mo, may weird na nangyayari. Okay? So may weird na nangyayari. Ano 'yon? Sabi niya, yung cathode ray tube daw, tas nandun sa dulo yung filament ng metal, nung kinuryente niya, may lumabas sa metal. May lumabas na ray. May lumabas na beam of light. So nagtaka siya. Sabi niya, ano yun? No? Kumbaga, atom lang yun. Pero nung kinuryente ko, may something. No? May lumabas from the atom. Okay? So, napaisip siya. Ibig sabihin ba nun, atoms ay gawa pa sa much smaller particles, no? So yun yung question ni Thomson. He asked himself kung ang atoms ba natin, yun na ba yun, no? Circle lang ba yan? Okay. Kasi nung kinuryente niya, may tumalsik mula doon. Ano kaya daw yan? Okay. So later on, in his inquiry, no, nung nag-test siya sa cathode ray tube experiment, nung ina-analyze niya yung data, nakita niya na ang atoms daw pala ay composed of negatively charged particles called electrons, no? Etong beams na tumalsik from your metal, yan daw pala ay stream of electrons, no? That is excited by the voltage, no? I mean electrical source, no? So nung na-excite ng kuryente yung atoms doon, nag-beam off siya ng electrons, no? So tumalsik yung mga electrons from the atoms there. Okay? And also, since alam niya electron yun, so he tested kung ano yung charge nun kasi physicist siya. So ginawa niya, he placed magnets, no? Okay, so isa positive magnet, yung isa negative end ng magnet. So tinest niya yon, and then he found out that the ray, no, or the electrons are attracted to a positive end, no, or a positive magnet, no. So attracted daw yung ray na yon sa positive end ng magnets. So ano yung nakita niyang idea dito na pandagdag sa atomic theory natin. So una is that atoms are composed of much smaller particles, no? So ibig sabihin may subatomic particles according to Thomson. Subatomic meaning mas maliit pa sa atom. Okay? So yun, Thomson hypothesized that the atoms are composed of subatomic particles, no? Which are called electrons. And electrons are negatively charged. Okay? So yan. So ibig sabihin ang ating atom, ganito na yung itsura niya. So hindi lang siya bilog, no? So kumbaga nag-hit na siya ng puberty niya. Nagkaroon na siya ng laman-laman sa itsura niya, no? So hindi lang siya bilog na. May tuldok-tuldok na sa ating atoms. And yung mga tuldok na yon, those are called the electrons. Okay? So nag-puberty na yung ating atom, no? So hindi lang siya bilog na, tuldok-tuldok na. Okay? Then, nung kinuryente yan, yung mga electrons na yan, yung tumalsek, no? To form the cathode ray. Okay? So, ganun. So, yan. So, nag-improve na tayo. Nag-umpisa tayo from bilog lang. Okay? Ito yung Democritus Dalton na itsura ng atom. Ngayon, naging bilog na may electron sa loob, no? Ang tawag dito ay plum pudding model, no? So what is a plum pudding? That is a delicacy in England, no? So kumbaga yan ay parang cake na may raisins ata yan. Okay. So ayan, so plum pudding model, no? So parang yung cake na may ah, sprinkles. Yung mga sprinkle na yan yung ating electrons. Okay? So, yan. So, nag-improve na tayo. So, we started with FEWA. Okay? So, nag-umpisa tayo sa FEWA ni Aristotle. And then, later on, nag-improve yan into atomos. And then, si Dalton, ano ginawa? In-explain lang ano yung atomos at ano yung mga pwede mo gawin sa atomos. And then, later on, si Thomson, kinoryente niya yung atomos, no? Kinoryente niya yung atoms, and he found out that there are subatomic particles in your atoms, okay? Which are called electrons, and they are negatively charged. He called the atomic model the plum pudding model. Okay? Uh, yeah. Okay. So next one is this one. Okay. So during Rutherford's time, Ernest Rutherford, no? So this is around World War One, World War Two na, no? So ano yung pinaka-major discovery noong World War Two? Atomic bombs, 'di ba? So sila rin yung mga may idea about this, no? Sa mga atomic bombs, no? Kasi hulaan nyo, ba't yun na-discover? Kasi inaalam pa nila yung atoms during that time, no? Okay. So one of the scientists, no? One of the chemists that investigated on the properties of atom is Rutherford, Ernest Rutherford, no? So, nung tapos na yung idea ni Thomson, si Ernest Rutherford, in-improve niya pa yan, okay? During Ernest Rutherford time, they were able to identify na ang ating atoms, they may be radioactive, no? Through the help of Madame Marie Curie and her wife, her husband pala. Okay. So, sina Madame, Marie Curie, pati yung asawa niya, si Pierre Curie, tapos sina Becquerel and other friends, no? Pati si Rutherford, sila nag-investigate on the radioactivity of our atoms. Okay? And then they found out na yung ating atoms pala, hindi lang siya gawa sa electrons, no? So kumbaga, hindi lang siya electrons. Meron din daw siyang nucleus, no? That's why they called their atomic model the nuclear model. Okay? So, ganun yung idea ni Rutherford. So, hindi lang siya plum pudding. So, sabi ni Rutherford, yan ay nuclear model. Ano yung itsura ng nuclear model? Ito, para siyang Jimmy Neutron logo. Okay? So, sabi ni Rutherford is that, dito na lang ako sa gilid. 'Di ba, we started with this, naging plum pudding. Then, later on, naging nuclear model. Yan. Okay, so isa-isahin natin paano naging ganyan. Okay, so according to these people, especially Ernest Rutherford, na yung ating atoms hindi lang electron meron dyan, meron din yung positive center, okay, which is called the nucleus. Okay, so this is the positive center, meaning ng positively charged, no? Positive center called the nucleus. And then around it ay yung electrons orbiting the nucleus. Okay? So yan. So yan yung nuclear model. Question, paano niya nalaman yan? Okay? So, si Rutherford, ang ginawa niya ay ganito. Gumawa siya ng gold foil experiment. Wala siya sa PowerPoint kaya kinukwento ko na lang na limited yung nasa PowerPoint natin. Okay, so kabisado naman natin kaya note nyo na lang. Okay, so yun. So excuse me. So Ernest Rutherford investigated atoms using his gold foil experiment. Paano yon? Okay, di ba si Thomson, ang ginawa niya, kinoryente niya yung atom. Ito naman si Ernest Rutherford, ang ginawa niya is that ganito. Meron siyang radioactive material dito. Okay? So, yan yung radioactive material or radioactive atom. Okay? So, that's radon ata. Radon yung gamit niya ata. No? And then, naka-enclose yon sa lead. Okay? So, na-enclose yan sa lead block. No? So, the purpose of the lead block is to contain the radioactivity. Okay? So, para naka-close lang siya dyan. Para isolated. And then, ang ginawa ni Ernest Rutherford, binutas niya yung isang part doon. So, binutas niya yung isang part. And then, ang ginawa niya is, ganito. Ano ginawa niya? Nung binutas niya yung block na yon, what happened is that, edi syempre, nag-shoot doon yung radioactive particles. Okay? So, nag-shoot doon ang radioactive particles. And then, at the end, meron siyang fluorescent screen. So, ano yung purpose ng fluorescent screen? Para kuminang yon, no? Liliwanag yon kapag may radioactive particle na tumama doon. Okay? So, ganun lang. So, binutas niya yan. Tumalsik yung radioactive atoms doon. Okay? Nung tumalsik yon, liliwanag yung part na yon. Okay? So, ang sumunod na ginawa ni Rutherford is ganito. Siyempre, mayaman siya. Meron siyang gold. Okay? So, ginawa niya, sa gitna ng experiment niya, doon niya nilagay yung gold foil. Tapos, hulaan nyo ano nangyari. So, expect natin na dire-diretso lang dapat yung radioactive particles, di ba? Kasi yun yung sabi ni Thomson na ang atoms, ganito yung itsura. So, if you have radioactive particles, kailangan tatagos lang siya. No? Kailangan tatagos lang yun doon sa atom. Okay? So, yun yung ina-expect nila. No? Nung nilagay ni Rutherford yung gold foil, ina-expect niya may isang point lang na may kita sa fluorescent screen. Okay? Kaso, ang nangyari is that instead of seeing just one point, ang na-observe niya is ang daming points, no? Kumbaga, nag-scatter ang light, no? Yung iba nga daw, bumalik pa, no? Nag-bounce back, no? So instead of just seeing one point of light, no? Rutherford saw multiple points of light, no? Dun sa kanyang film around itong film niya to, film, okay? So nakita niya ang daming point, no? Sabi niya, bakit ganun? Kasi kung ang atomic model natin ay yung kay Thomson, tatagos lang 'yon doon. Okay? Kaso ang problema sa case natin na to, nung nilagay natin yung gold foil, may mga tumalsik. So nagtaka sila bakit? Kasi sabi nila mali si Thomson. Okay? So mali yung kanyang drawing ng atom. Kasi kung ganito lang yan, kung ito lang yung atom, tas may tuldok-tuldok lang ng electron, tatagos lang dapat doon yung mga particles. Okay? According to Rutherford, that's wrong. No? So Rutherford hypothesized that there is something in the atom that causes repulsion. Okay? So it causes repulsion of the uh, rays emitted by this radioactive source. Ano ba yung rays na ini-emit ng radioactive source na yan? Yung alpha particle, no? Or helium atom. So, yun, may alpha particle yan, which is positively charged. So, nung tumama daw yung positively charged alpha particle sa gold foil, pwedeng may natamaan yun na something, kaya tumalsik siya pabalik. Okay? So, isip sila. Okay? So, isip sila, ano kaya yung reason ba't tatalsik pabalik yung positively charged alpha ray from the radioactive atom? So, isipin nyo na lang yung magnet, no? If yung magnet nyo, parehas sila ng charge, pag pinagdikit mo, what will happen? It will repel each other, di ba? Nara, ito, negative end ng magnet, negative end ng magnet. Pag pinagdikit mo yan, what will happen? Magbabounce back yan. So, yun yung idea nila dito. They know that the alpha particle is positive, no? That's given by Marie Curie's idea, di ba? And Henry Becquerel's idea. Okay, so alpha particle is positive. Nung tumama siya sa atoms ng gold, may natamaan siyang positive din. That caused it to bounce back. Okay? And if madikit lang siya dun sa positively charged particle dito sa gold atoms, pwede din siya mag-deflect. Okay? So ang cause ng deflection and yung pag-bounce back ng mga rays ay yung positive din sa gitna ng atoms. Okay? So kumbaga, sabi nila, yung atoms hindi lang siya ganyan. Okay? So hindi lang siya ganito. Okay? Kumbaga, the positive center of the atom is compressed in the middle, no? So hindi siya scattered, no? Ano siya, compressed, no? Compact yung positive center ng atom na yun. Okay? So itong positive center na to, pag yan yung tinamaan ng alpha ray, magba-bounce back yung alpha ray, pwede ring ma-deflect. Okay? Kapag hindi niya yan tinamaan, doon pa rin siya sa original point tatama. Okay? So dito pa rin sa original point sa baba siya tatama. Okay? So yan. Pero ang kapag siya ay nadikit or tumama mismo sa sa positive center ng atom, magba-bounce back or magde-deflect, no. So that's why Rutherford stated na yung atom ay may nucleus, no. And the nucleus is positively charged. Okay? May electron pa rin, pero sabi niya, may nucleus din, okay? So ibig sabihin, dalawa na yung ating subatomic particles, no. So we have the atom which is composed of electrons and the nucleus, no. So yun, that was discovered through the help of Rutherford's gold foil experiment or alpha scattering experiment. Okay? So yun yung mga later discoveries nila. So ganito na yung itsura ng atom natin during his time. Okay? So Jimmy Neutron logo na yun. And then later experimentation, yung mga later experiments, no, done by future scientists, for example si Chadwick, no, doon nila nalaman na yung nucleus ay composed pa pala ng different particles, no. So si Chadwick, ang pinaka summary ng ginawa niya lang is that he investigated on Rutherford model. So inimbestigahan niya yan, tapos when he X-ray talaga yung ginamit. Yes, X-ray. So, nung in-X-ray niya yung atoms natin, he found out that there is something in the nucleus that do not have charge. No? Bakit? Kasi isipin nyo daw, sabi ni Chadwick, if ang nucleus ay puro positively charged, how come na magdidikit-dikit sila? Yun yung sabi ni Chadwick. Pero totoo naman, 'di ba? Yung magnet nga pag pare-parehas positive, 'di ba? Naghihiwalay. What if the nucleus is completely positively charged ng laman niya, no? Ano daw mangyayari doon? Eh di dapat nag-deflect na 'yan, no? Kasi magre-repel yung mga 'yan eh. Okay? So that's why nung in-X-ray ni Chadwick, may nakita siyang neutral charges sa nucleus, no? Walang charge and they cushion the positively charged, no. Kumbaga sila yung sila yung bubble wrap ng mga positively charged particles, no. Okay, so yung mga neutral charged particles, sila yung mga nagba-border dun sa positively charged particles para magsama-sama sila. Kasi tignan mo, kapag yung magnet, lagyan mo ng papel sa gitna, or let's say, lagyan mo ng libro sa gitna, magre-repel pa ba sila? Hindi na. So, yun yung idea ni Chadwick, no? That there is something that is neutral inside the nucleus of an atom. And he called it the neutrons. Okay? So, neutrons are the neutral charged particles inside the nucleus of an atom. Okay? So, nag-expand na talaga yung knowledge natin ng atom dito, no? So, kumbaga, we started from this. We started from this model, yung bilog lang. This is from Dalton and Democritus. Naging plum pudding upon the discovery of electrons ni J.J. Thomson, John Joseph Jones, J.J. Thomson. Okay, so John Joseph Thomson. And then later on, that was improved by Rutherford. So ano napansin ni Rutherford, may ganyan na. Okay, so meron na daw nucleus, no? Nucleus. Ito kay Ernest Rutherford. And then later on, kay Chadwick, nalaman niya na James Chadwick ito. Tapos nung kay Chadwick, nalaman niya na may neutron yung ating nucleus. Okay? Okay? So kumbaga, you have your electrons here, pero yung nucleus that is further composed of two particles. Okay? So ano yung dalawang particles sa nucleus? You have your neutrons and then you have your protons. No? So kanino sino yung discoverer ng protons? So yung discovery ng proton, which is the positively charged, nire-name lang nila. No? Ina-attribute na lang nila kay Rutherford. No? So yan. So we have the three subatomic particles now. So we have the electrons, which was discovered by J.J. Thomson. We have the neutrons, which was discovered by James Chadwick on his X-ray experiment sa atom. And then we have the proton, which was attributed to Rutherford's discovery of the nucleus, no? Kasi positively charged daw. E di sa kanya na yun, okay? So, yun. So, lumawak na yung understanding ng atom. So, hindi lang siya bilog, kundi siya ay marami pa palang laman sa loob na. Okay? So, future scientists were able to get a clearer picture of our atom, no? So, gumawa sila ng more sophisticated experiment because nag-improve yung science during time, yung technology nag-improve din. So, hindi na sila nasatisfy sa ganitong model lang ng atom, sa nuclear model. Excuse me. So, andyan pumasok si Bohr. So, si Niels Bohr, siya ay isa sa mga modern scientists that investigated on the atom. So, according to Bohr, yung ating electrons daw, hindi lang siya basta-bastang nakaikot sa nucleus, no? 'Di ba kay Rutherford ang electrons basta ikot-ikot lang 'yan. Sabi ni Bohr, hindi 'yan ganyan, no? According to Bohr, our electrons orbit, no? Orbit the nucleus in certain energy levels, no? May energy levels ang electron. Okay? So, per energy level, ibig sabihin may corresponding energy for the electron, may corresponding speed, no? So parang ano niya, ni-relate niya yan sa solar system. Okay? So yan. So that was Niels Bohr idea. Ano yung pinaka nagbago dito? Instead na yung ating electrons, kalat-kalat lang sila, sabi ni Bohr, yung ating electrons, they occupy certain energy levels in orbit. Okay? And that was his planetary model. Okay? So, ang tawag natin sa atom ngayon ay planetary planetary model na. Okay? So, per energy level, may corresponding number of electrons. Okay? So, for the first energy level, 2 electron lang. For the second energy level, 8 lang, and so on. Okay? Kumbaga, ito yung pinaka-start ng quantum numbers, no? Yung quantum numbers next week na lang natin i-discuss na. Okay? So, ganun lang. I mean, hindi next week, next meeting. Okay? So, si Niels Bohr, siya yung pinaka nag-start ng idea ng quantum numbers. Okay? Because ang first quantum number ay energy level, di ba? Okay, so ito yon. So sabi ni Niels Bohr, yung ating electrons, hindi lang yan basta kalat-kalat, they occupy certain energy levels na. And later on, that was used to describe the shape of the electron. Yung energy level, nagamit din yon to further improve the image of our atoms during that time. No? Then we came up with a quantum mechanical model which is used today. No? So ganito na yung itsura ng atoms natin. Hindi na siya naka-orbit lang. So, ano yung changes dito? According to quantum mechanics, no, yung energy level daw na yon, hindi naman talaga orbit yon. Kumbaga, shape yon. Okay, so depending on the energy level occupied by the electron, there are corresponding shape for the atom. So pwedeng spherical shape, pwedeng dumbbell shape, pwedeng clover leaf, and pwedeng complex shapes. Doon na pumasok yung SPDF shapes. Okay? So itong SPDF, yan yung mga shape ng ating electrons when they occupy certain energy levels. So hindi na siya bilog-bilog lang na orbit. Kumbaga, nagiging shape yan, okay, in 3 dimension. Okay? So yun. We will discuss this more next meeting, okay? So, bakit ko maaga i-dismiss kayo? Kasi I want you to review for tomorrow, okay? So ganun lang. Mabilisan lang muna tayo. Okay, so balik tayo. Ayun na yung pinaka-entire history ng atoms. So, again, recall ulit tayo from the top. Recall ulit natin para mas makita natin yung clear progression. So, we started with Phewa ni Aristotle, and that was contested by Democritus. According to Democritus, everything is composed of indivisible particles called atoms or atomos in Greek language. And then in the modern times, we have Dalton who investigated on the atoms as well, and he found out that Democritus was right, okay, that atoms consist everything, okay. So he came up with several experiments, and that resulted to the formation of his atomic theory, which has 4 postulates. Number 1, all matter is composed of atoms, indivisible particles yung mga yon. Number 2, each atom of certain element has certain chemical properties. Number 3, in any chemical reaction, the atoms are not replaced, no, nor they do not disappear as well. Okay? So ganun. So, ibig sabihin, the atoms are conserved, no? So, kung ano yung atoms mo before and after the reaction, same lang yan. And then lastly, when you combine your atoms, you form compounds and molecules, no? Which has distinct chemical properties compared to your elements. So, yun yung Dalton's atomic theory. And then later on, we have Corriente, because industrial revolution na to. We have J.J. Thomson. Okay? So, si J.J. Thomson, so anong ginawa ni J.J. Thomson? Kinuryente niya yung atom in his cathode ray tube. Then, he found out that there is a ray, a beam of light, no, emitted by the atoms when they get excited. And then, with his further experiments, he found out that the ray of light is negatively charged, so he called it electrons. Okay? And then he modified the atomic model from just a spherical shape into a plum pudding model, wherein the electrons are embedded on the surface of the atom. The image of the atom was further revised by Ernest Rutherford, or Rutherford na lang. Okay, so nirevise yun ni Ernest Rutherford upon the discovery of radioactivity by Marie Curie and Pierre Curie, and then Henry Becquerel, no? So yung mga taong yon, they discovered radioactivity, and ginamit yon ni Rutherford to further assess the atomic structure. Okay? And then he found out that the atom is not uh, the same as the plum pudding model. So hindi lang siya electrons with embedded on the surface of the atom. Kumbaga, the electrons are orbiting around the nucleus of an atom, which is positively charged. Okay. So he changed the atomic model from plum pudding to a nuclear model. So you have your nucleus, and around it ang electrons. Si Chadwick naman, he x-rayed the atom, and then he found out that yung nucleus natin, the reason why they are stuck together, but sila magkakasama together, is that meron kasing neutral particles, no, that hinder the the repulsion of the positively charged particles in there. Okay, so that's called the neutrons, no. So they serve as cushion for the positives, no, para magsama-sama sila sa nucleus. Okay, so ganun pa rin yung model niya. So, ano lang nagbago? Meron lang neutron, and then yung nucleus pinalitan ng proton. So, tatlo na yung subatomic particles natin. We have proton, which was discovered by Rutherford, the neutrons, which was discovered by Chadwick, and then the electrons, which was discovered by J.J. Thomson. And then later on, um, sabi ni Niels Bohr, okay, that our electrons do not just orbit randomly. Instead, they take up orbits, no? So hindi lang I mean, parang ang redundant pala ng sinabi ko. So, sabi ni Niels Bohr, yung ating electrons, they just don't travel around randomly sa ating nucleus, no? Instead, they take up certain orbits, no? So, they occupy certain energy levels, no? Depending on the number of the electrons that is present in your atom, okay? So, he revised the atomic model into his planetary model, okay, wherein each orbit will represent certain energy level. So, Bohr model yan. Okay. However, no, upon the improvement of the technology, we found out that yung ating energy levels, hindi lang pala sila orbit talaga. Hindi lang sila two-dimension circles. Kumbaga, may shape yon. Okay, so hindi lang siya circle. May corresponding shapes yon. So that's why we have the SPDF, no? The spherical, the dumbbell, the clover leaf, and the complex shapes, no? So, yun. Yun yung provide ng quantum mechanical model. Okay? So, ma-discover natin yan more next meeting, no? Sa Friday. So, ayan. So, balik na ulit tayo. So, yun lang yung history niya. So, let's go back here. Ito yung pinaka-madaling representation ng atom eh. So, we have the nuclear model here. Okay na yan for representation purposes lang. We know that our atoms are composed of three subatomic particles. No? So, we have the proton in the nucleus, the neutrons in the nucleus, and electrons in the outer part, no, of the nucleus, no. So kung mapapansin niyo, no, yung proton yung dark blue, and then yung neutrons sila yung light blue. So kumbaga they cushion the positives, no. Parang they form the barrier, no, between the positive protons, no, so that they will not repel, para magsama-sama sila. Okay? So yun yung purpose ng neutrons, no, to serve as borders, no, to 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 ano to protect proton from a proton. So ganun lang yung purpose niya. Para hindi sila mag-deflect from each other. Okay? So yan. And then later on, these are the later discoveries. Nalaman nila yung mga properties of the subatomic particles. For example, nakuha nila yung mass ng particles na yan, yung mass nila, and then yung corresponding charges nila. Okay? So, what can we notice is that the mass of the atom is concentrated inside the nucleus. Okay? So, yung mass ng atom ay yun kung ano yung nasa nucleus lang. So, that means the atomic mass is the sum of the proton and the neutron. Okay? So, kung ano yung mass ng proton at kung ano yung mass ng neutron, pag pinagsama mo yon, that represents the mass of the atom. Okay? Kasi yung neutron daw, that is very light, no? So masyado siyang magaan, no? For it to affect the mass of the atom, okay? So, yun. Pero yung charge ng ating atoms, no? Ang dahilan kung ba't may charge yung ating atom is yung proton and electron, okay? So the atomic charge is the sum of the protons and the electrons, no? So pag pinag-add mo yung proton and electron and they are equal, that means your atom is neutral, wala siyang charge. Pero kunwari, sumobra yan ng proton, then your atom is a positively charged ion, okay? Magiging ion yan. Pero kapag sumobra ka naman ng electron, your atom becomes negatively charged particle, okay? So yun. Again, so yung charge ng ating atom, attributed yan to the number of protons and electrons. Kung sino yung sobra, yun yung charge ng atom. Sa mass naman, that is attributed to the sum of the number of protons and neutrons. So pag pinag-add mo yung proton and neutron, that will give you the atomic mass. Okay? And then we represent those information with a nuclear symbol. Okay? So ano yung itsura ng nuclear symbol? Okay, so ganito yung itsura ng nuclear symbol. So the nuclear symbol looks like this. Okay? Ito na lang sundin nyo yung sinusulat ko. Okay, so yan. So ito yung itsura ng nuclear symbol. You have your X, which is your element symbol. So ano yung element symbol? Yan yung one or two letters that represent the element. Okay, so for example, hydrogen, H yan. For helium, that's He. Okay, so yun yung value ng X. So piliin nyo na lang sa periodic table yon. Okay, so that identifies kung anong element yung tinutukoy natin. Etong number sa baba, sa lower left, tawag dyan ay atomic number. Kaya, ba't sumobra ng E? So, atomic number yan, kaya number sign yung nilagay ko para mas madali ninyo maalala. So, again, yung number sa baba, sa left, yan ay atomic number. So, ano yung meron sa atomic number? The atomic number represents the number of protons of your atom. It tells you about the number of protons of your atom. Okay? Kung ilan yung proton, ganun karami yung atomic number niya. So that means 1 to 118 yan. Okay? So kapag isa yung proton, hydrogen yan. Pag dalawa yung proton, helium yan. Pag tatlo, hydrogen, lithium yan, and so on and so forth. Okay? Okay. Excuse me. Okay, so the number here sa top left yan, di ba? Okay, sa top left, ang tawag din sa number na yan ay atomic mass. So, saan gawa yung atomic mass? Edi sa number ng proton plus neutron. Okay? So, pag pinag-add mo yung dami ng proton and yung dami ng neutron, you will get your atomic mass. And then the number at the top right side of your symbol, etong C, this is the charge. No? So the charge could be positive, pwedeng negative, pwedeng zero. Okay? So depending on the number of protons and the number of electrons, you will have a corresponding charge for that. Okay? So again, erase natin para mas makita nyo clearly. So you have your tawag dyan, element symbol. Okay? Tawag dito sa number sa bottom left ay atomic number. So atomic number is equal to the number of protons. Okay? So ganun lang. So the number at the top left, ito yung top left, that's called the atomic mass. Now, how do we solve for the atomic mass? That is just the sum of the proton plus the neutron. Okay, pagpa-plus mo lang dalawa, you will have your atomic masses na. And then, the number at the top right is the charge. How do we solve for the charge of an atom? That is proton minus electron. So kapag sobra ng proton, that will be positively charged. Pag sobra ng electron, that will be negatively charged. No? However, if they are equal, then your atom is neutral or it doesn't have any charge. So I want you to remember this now. Okay, so kabisaduhin nyo na to. Okay, so ayan. So let's try to look at this example here. Although may sagot na dun sa gilid. Ayan. So, using this symbol, alamin natin kung anong element yan. Let's identify anong element yan. Kung ano yung number of protons niya. kung ano yung number of neutrons, yung number of electrons, and yung charge niya. So, identify natin yan. Dito na lang yung charge. Okay. So, if you are given this symbol, you can identify all these 5 info. Okay. So, paano mo gagawin yan? Okay. So, ganito lang. Ang first na titignan mo dyan is the number at the lower left. 29. So, yun na yung number of proton agad. Okay. Paano mo malalaman kung anong element yan? So, you must have your periodic table with you. Okay. I have one here with me. So, hanapin mo sa periodic table anong element yung number 29. Okay, so that's copper according to the periodic table. Kung ano yung element number 29, ibig sabihin nun, 29 protons yon, which is copper. Okay, so copper daw yun. Copper. So, ano yung symbol ng copper? Cu. No? Sabi dito. Okay? Ano pa? Tatlo pa kulang natin. Charge, neutron, electron. So, paano yan? Ganito lang. Di ba you have your atomic mass here? 64. Saan gawa yung atomic mass? Proton plus neutron. Okay? So, that means in equation, that is mass equal proton plus neutron. So, that's 64 equals proton is 29 and neutron is unknown. So, ano i-add mo sa 29 para maging 64? Kakalky ko na lang. Okay? Para tama. I-calculate nyo na lang. Huwag nyo na i-mental. So, ano i-add mo sa 29 para maging 64? That's 35. Okay? So, that means the number of neutron for this element is 35. Okay? So, yan. 35 plus 29, 64. Okay? So, yun yung atomic mass. Dalawa na lang kulang natin. Charge and electrons. So, ano papansin nyo? Is there a number at the top left, top right side of the symbol? Wala. Walang number na nakalagay dito. Kapag walang number na nakalagay niyan, that means the charge is 0. Kapag 0, hindi na natin sinusulat. Okay? So what does it mean kapag 0 yung charge? So it means that the number of proton and the number of electron are the same. Okay? So 29 yung proton, 29 din yung electrons. Okay? So, kapag walang nakalagay doon, kung ano yung dami ng proton, yun din yung dami ng electrons. Sir, what if, kunwari, yan ay positive 2? Okay? So, that means, kung yan ay positive 2, burahin ko to, gawin natin positive 2. Kung ito ay positive 2, that means, yung proton, the same pa rin yan. Okay? So, hindi magbabago yan kasi copper yan eh. So, ibig sabihin, magbabago yung dami ng electrons. Okay? Ang problema, ilan yung electrons para maging positive 2 yung charge? Ano yung formula uli? Sabi natin kanina, charge is equals to proton minus electron. Ano yung charge? Positive 2. Ano yung proton? 29. Ano yung electron? Hindi mo sure. So, ano yung isusubtract mo sa 29 para yan ay maging positive 2? Okay? Solve mo yan. So, ano yung susubtract ko sa 29 para maging positive 2 ang difference? Di 27. Okay? So, that means my electron is 27 for this atom. Okay? So, kapag 29 minus 27, positive 2 yung sobra. Okay? So, yun yung charge. So, ganun lang. Okay? So, that's how we identify the number of subatomic particles in an atom just looking at the nuclear symbol. Again, this is your element symbol. This number at the bottom left is your number of proton or your atomic number. The number at the top left is your atomic mass, which is the sum of proton and neutron. So kapag pinag-add mo yung proton and neutron, that must be equal to that number. The number at the top left, top right, is the charge. If walang nakalagay dyan, that means the charge is 0. However, if may nakalagay dyan, you have to solve for the value of the electron. So that's charge equals P proton minus E electron. So pag subtract mo lang yung dalawang number, kung ano yung difference nun, yun yung corresponding charge. Okay? So that's how we will know kung ilan yung proton, electrons, neutron, and yung charge ng isang element. Okay? So keep in mind lang yung equations na iyan. Okay? Magagamit natin yan sa future. Okay, punta na tayo sa last part ng discussion for now. Last part for now. Okay, for now. Kasi i-cut ko na yung class early para you have time to review for tomorrow. Okay? Alam ko ako ata last class nyo eh. So, kung mapapansin nyo, itong periodic table natin, punta tayo dito sa periodic table. Mamaya mabuksan ko ML. Yan. Punta tayo sa periodic table. Tignan nyo yung atomic mass. Ano yung nakalagay? 1.008. Ano nakalagay? 12.001. 58.933. So on and so forth. So, kumbaga, may mga decimal. Kala ko ba ang atomic mass ay proton plus neutron? Diba? Whole number yon, sir. Paano nagkaroon ng decimal? Because, ganito kasi, yung isang element, may different versions yan. Okay? So, hindi yung ating element, hindi yan nag-exist as one form lang. It exists as many forms. No? We call them isotopes. No? And ito yung nakita ko last time sa Facebook na may fake news. No? Ano sabi sa post na yun sa Facebook? Ang Pilipinas daw ay rich sa deuterium. Okay? So that's very ridiculous because deuterium is dangerous. So medyo dangerous yan. Imagine yung pag-reach sa ganun yung Pilipinas, patay na tayo. Okay. So ano sila? Wala silang alam sa science. So kailangan manahimik na lang sila. Okay. So yan, yung mga deuterium, hydrogen, tritium, they are called the isotopes. No? They are versions of one element. Okay? So yung isang element, maraming version yan. Okay? Excuse me. I still have cough kasi chronic chronic cough. Okay. So anyway, so yan, yung isang element natin, maraming versions yan. Ano yung nagbabago sa kanila? So, hindi pwede magbago yung atomic number. Bakit? Kasi kapag nagbago yung atomic number, yun ay ibang element na. Okay? So, for isotopes, they still have the same atomic number. Okay, same atomic number. Hindi kita yung blue. Hindi rin kita to. Ano ba yan? Dito na lang ha. So for isotopes, they have the same atomic number. So same lang yung atomic number nila. Ano yung nagbabago? Yung number of neutrons. So magkakaiba sila ng number of neutrons. Therefore, yung kanilang atomic masses ay magkakaiba. So magkakaiba sila ng number of neutrons. That means their atomic masses are different as well. So yun yung isotope. So they have the same number of protons, yet the number of neutron differs. Okay. So depending on the atomic mass or the number of neutrons, you can have multiple isotopes for one element. Okay. So for hydrogen, ito yung tatlong yon. So we have the protium, deuterium, and tritium. Ito yung nasa fake news, which is very wrong. Okay. And for carbon, there are certain versions of it, such as carbon 11, carbon 12, carbon 13, carbon 14, and so on and so forth. Okay. So ngayon, hindi ko pa rin nasasagot. Sir, paano nagkaroon ng decimal point itong ating atomic masses sa periodic table? So the answer there is ganito. In order for you to get the average atomic mass, no? Wala yun dito eh. Excuse me. Wala nga dito. So in order for you to get the average atomic mass of your element, no? Kasi kung mapapansin nyo, yung hindi mo pwede ma-isolate yung isotopes kasi atoms yan eh. So iba-iba yung isotopes talaga sa isang element, 'di ba? So hindi mo sila mapaghihiwa-hiwalay. So ang pwede mo gawin is to get their average, no? Tawag doon ay average atomic mass. So ginagawa natin is that yung nire-report sa periodic table na atomic mass, that is the average of all the isotope mass. Okay? So ano yung equation nun? Ito, next meeting natin to gagamitin. Okay? So ano yung equation natin for average atomic mass? So that is the sum of the fractional abundance times the isotope mass. FAIM. Okay? So fractional abundance So, ano yung fractional abundance? Yan yung percent, no, ng element na to overall. Okay, so, for example, yung hydrogen 1, that is 99%. Tapos yung deuterium, that is 0.05%. No? So, yung mga percent na yun yung fractional abundance. Tapos, ito naman, ito yung isotope mass. Okay? So, that is given. So, gagawin lang natin, i-multiply natin yung fractional abundance times the isotope mass, and that will give us the average atomic mass. No? So, before we end, I will give you some example. Bigyan ko kayo isang example na lang muna. So, I want you, after this, save nyo na lang muna yung notes natin. Kasi I want you to have time to review for tomorrow eh. Save nyo na lang muna to kasi di-discuss din naman uli natin to sa kailan ba? Sa Friday. Kuha tayo ng atomic data. Punta tayo dito. Kunwari ito. Hindi ko, tignan ko, pwede siya lakihan. Sige. Ito. So, for chlorine, okay, so for chlorine, we have two isotopes, chlorine 35 and chlorine 37. Ang gagawin natin is to solve for the average atomic mass. Okay? So, lista muna natin yung data. So, again, for chlorine, we have two isotopes, chlorine 35 and chlorine 37. Okay, so for us to solve for its average atomic mass, kunin muna natin yung fractional abundance ng dalawang isotope. So balik ulit tayo dito. Chlorine 35 is ang abundance niya ay 75-76%. Ito susulat natin doon. And then for chlorine 37, yun yung 24%. Okay, so pag pinag-add ton dalawa, that will give us 100%. Okay, so okay na tayo sa fractional abundance. Next one is IM. Ito yung isotope mass. So 34969. Then for chlorine 37, that's 36966. Okay, copying ko lang. Okay, so with all this info, kunin natin yung average atomic mass. Kompleto na naman tayo. Okay. Kung ano yung makuha nating average atomic mass, ito yung ilalagay nila sa periodic table. Okay, so let's try. Okay, so ano yung formula natin? Average atomic mass. Let me write it in red para mas kita. That is the sum of Fa times Im. So, anong gagawin natin? So, yung Fa, i-multiply natin sa Im. So, this times this times this. Okay? Then, saka natin i-add lahat. Okay? So, i-add natin lahat. However, in multiplying your Fa with Im, this must be expressed in decimal form. Okay? So, let me do that. Pindot ko pala yung mute. Okay. Kakapindot ko ng keyboard. Nitong mouse. Okay. So, anong mangyayari sa atin? I-multiply natin yung Fa with Im. Okay. So, paki-ready calculator nyo. However, we are going to convert Fa to decimal. Okay. So, yung 75.76% that can be expressed as 0.7576 times your Im, your isotope mass for chlorine 35, which is 34,969. Plus, for the other isotope, chlorine 37, so that will be 0.2424 times the mass, which is 36,966. Okay. And that's all. Okay. So, yan. Ganun lang gagawin nyo. You multiply Fa and the Im. Okay. So, this times this times this. Okay. So, i-multiply nyo yung dalawa. And then, saka mo sila ipag-add. Okay. So, paki-calculate na lang to para tapos na tayo agad. Okay. .7576 times 34,969 plus 0.2424 times 36.966. Okay, and then the average atomic mass is 35.45. Okay, 453. Okay, so yan yung average atomic mass ng chlorine. So kung ang gagawin natin is to verify that, look at your periodic table. So this is my periodic table. Kung titignan niyo yung chlorine dito, nakalagay ay 35.45. 453. Okay? So that means the atomic masses that are shown in our periodic table is the average of the isotope masses and their fractional abundances. No? So yun yung sagot. No? Bakit may decimal point sa periodic table? But hindi siya whole number? Okay? So ganun lang. Okay? So yan lang. That's all for today. No? Hanggang na muna tayo. Okay, so I want you to review for next meeting. Review for your quiz tomorrow para by next meeting, focus na kayo uli. So, before I end the class, no, tomorrow, during the quiz, no, hindi naman necessary na tomorrow agad kayo magku-quiz, no. So you pick your free schedule, no. So pwede kayo sa Wednesday, pwede kayo sa Thursday, pwede kayo sa Friday, pwede sa Sabado. Okay? Basta may time limit lang, no, until 12 until before 12 sa Sabado, 12 midnight. Okay. So ang gagawin ko for now is that after this class, no, siguro mga Wednesday or sa Thursday, mag-upload ako ng worksheet, no. So mag-upload ako ng worksheet which will include yung pagbibilang, no? Counting protons, neutrons, electrons, atomic mass, and the charge. So I want you to answer that na, no? Para by next meeting, sagot na tayo agad. Then continue tayo sa discussion. And then with that also, meron tayong worksheet for the average atomic mass. Okay? So ito yung mga about isotopes, no? So sagutan nyo na rin yan. So ganito lang naman yung equation. So madadali lang, okay? So I want you to work on those questions para by next meeting, makapagsagot na kayo. And then we will continue our discussion about the atoms. Okay? So, malapit na kasi tayo matapos. Kaya okay lang, mag-chill muna. Okay? So that's all for today. Do you have any questions or clarification, or we're good to go? Okay. So I think we're good na, no? Again, para sa mga classmates nyo na hindi aware na nag-start na tayo, parang wala pa naman ako gano'n na encounter dito. Okay, pero just in case may classmate kayo na hindi aware na nagkaklase tayo, let them know. Kawawa naman eh. Okay. So yung isa ko kasi student sa medical technology, di siya aware na nag-start na kami. Gulat siya may quiz na. Ako naman nagulat ako, no? Kasi chapter 2 na kami. So ganun. So, para hindi tayo magkagulatan, let them know na lang na we are conducting our lesson na. Sir, ilang beses po pwede i-take yung quiz 1? So, ako kasi, I will only allow one take lang. Okay? Okay, so I want you to do your best shot dapat agad. So, you have plenty of time naman. So, 90 minutes, 1.5 hour for 20 items. So, kung kukumputin natin kung ilang minutes per question, 90 divided by 1.5. Ay 90 divided by 20 questions, you have at least 5 minutes for each question. Okay? And yung questions naman dun, kung ano yung diniscuss natin, most likely ganun din, no? Mas tricky pa nga yung ibang diniscuss natin eh. Okay? Pero at least sanay kayo sa mga tricky questions. Okay? So I want you to answer it in one take lang. Okay, one shot lang. Bakit no? Kasi ako tinetrain ko kayo for the board exam. You only take the board exam once. After nun, pag pinasa mo, you will wait for the result. So ganun din tayo. Okay. So ganun talaga. Sanay ako sa one take lang. Okay? So one take lang, 90 minutes no. So yan. Alam ko kaya niyo yan. Okay. Nung kinonduct ko tong quiz na to last year, which is last year then. Okay. Marami naka-perfect. Okay. So hopefully marami maka-perfect din sa inyo dito. Okay? Madali lang 'yan. Kayang-kaya niyo 'yan. Okay? So yan. So good luck and I'll see you again on Friday. Again, please answer the worksheet that I will upload on Wednesday or Thursday. Doon ako mag-upload. So abang lang muna kayo. Okay? So that's all for today. Kain na muna, review para bukas. And galingan nyo po as always. So ingat and stay safe. Kain na po ng dinner. Bye-bye. I will upload the copy pala sa YouTube. Okay, para mag-review kayo. Bye-bye class.